Last session of the day, but it's been a great conference. I don't know if you have been kind of attending this conference for the last 2 days. A lot of awesome sessions, good content, and hopefully I'll add something over to what Scott just mentioned. So I'm Sachin Agarwal. A little bit about myself. I started off as a developer at Oblix. So I was one of the first guys at Oblix, along with a few other companies who kind of created this single sign-on. The terminology SSO was created back in '99 by these companies, created IAM, then moved on to Oracle, and now at SOA Software. At SOA Software, we do API management, SOA governance, API security, so anything around protocol, how data passes through these protocols, and then securing them. So what's an API? All of you kind of know about API. It's a programmatic way of taking your applications or services and exposing them to your customers, irrespective of where they're accessing that data or service from. It could be from Internet of Things, mobile, desktops, shopping carts, wherever, web browsers, or wherever they're doing it from. What's really, really important about APIs is not the programmatic access, not REST, JSON, all the new protocols that APIs support and make it really easy for consumption within mobile devices and now in the future IoTs. But it's also the other thing about APIs, which is the self-service nature of APIs. The way a large set of developers can come, look at an API, search for an API, look at the documentation and self-register and start using it. That essentially makes an API really, really attractive for mass adoption, whether it's internal, external, or within your partners. But that's, again, a very, very important aspect of why APIs in general are becoming so popular. I'm not such a big fan. I think REST and JSON is great, but again, REST and JSON is a protocol, and if we have been in the industry for long, we know protocols have a valid time frame. So REST and JSON is right now, who knows what's going to come tomorrow. There already talks about MQTT, AMQP, WebSockets, and other protocols which might or replace or at least complement JSON and REST in some sense or fashion. So let's kind of step back a little bit, go back to kind of early 90s and see how security kind of evolved from the early 90s. In those days, if you remember in early 90s, it was essentially most applications were client and server. There was a huge database wherein all your application logic, everything sat over there, and there was a heavy client that was sitting out there, which did most of the UI processing and maybe a little bit of business logic. And security in those days was achieved primarily through network isolation, which is essentially people only within the enterprise had access, who had those heavy client installed on their desktops, had access to those applications. So fairly good level of security. I mean, if you don't provide access, there's no hacks or the limited hacks. Limited users, so that was what was there in early 90s. Then in late 90s and early 2000, we had this web services, SOAP, a lot of like internet sites came up, and primarily security was achieved through SOAP, web services as we know it, SOA, SOAP, and all of that. And actually, it was quite extensive. Over a period of time, SOAP security and web services security evolved. You had SSL TLS, which obviously is pretty good and still should be used. But there was PKI and WS Trust and WS Services and a whole slew of standards around web services and SOA and XML and everything. It became adopted by B2B partners, but not so much your SOAP security, because it was so complex. It didn't get adopted by a mass majority of developers. And now if you look fast forward and look at now or look at the future, your applications and services need to be adopted by not only mobile devices, but cloud applications, social applications, desktops, and things like that. So how do you make security much more simpler on your API? And there's a concept about API security. How do you make API security? But also, when you're making this application and services available for a mass majority of developers, how do you make it really easy for these external developers or maybe internal developers but make it easy for them to onboard so that they can build applications, but at the same time, you need to enforce security. So there's the yin and yang of security with APIs, wherein you want to increase adoption, you want more and more developers to use your APIs, but at the same time, you want to make sure that your data is safe, your service is safe. So how do you kind of enforce end-to-end security? This is a very simplistic kind of different areas of what you should look at from an end-to-end security. You obviously have to secure your backend. On the mobile app, you need to make the user experience, the end user experience really, really simple. Log in, use the application again. I mean, don't have to log in again. Secure the data that's residing on the mobile application, which is your PII, personally identifying information, or health information, whatever that is, securing that data on the app. Make it really easy for those app developers, whether they're internal app developers or external developers, to consume the API and develop these apps, and then secure the channel, which is secure the channel through which, or secure the API channel through which your data is flowing. Another point, if you look at the security landscape, there are a lot of vendors in the security landscape. So where exactly does API security come into play? So if you look at, there's all the single sign-on, identity and access management, and now IDAS vendors. The list of vendors are out there. They're essentially in the space of authentication and authorization. So that's what they do. And there's ping obviously in there too. There's mobile device management that's specifically around mobile security, encrypting your apps, containerizing your apps, securing your password within the apps, securing your access to which apps, enterprise apps you're allowed or not. And there's a whole slew of other vendors like advanced threat protection, there's firewall, there's intrusion protection vendors that provide gateways. There's all kind of different kind of gateways out there, virus scanning companies. But then there is something very, very specific to API security. And not all of these kind of different segments of security address the things that are very specific to API security. Protocol-specific threats, whether it's a SOAP, then SOAP-related, XML-related, WS security with APIs, there's OAuth, there's JSON-specific threats. Key management, OAuth. Where do you put OAuth? Where do you manage licensing? Where do you manage monitoring? And I'm going to talk a little bit about all of these things, like what's licensing, what's monitoring, why is it important for API, and then where do you kind of really inject all of this in your infrastructure. So if you kind of look at API security end-to-end, on the right you have your applications and services, and then towards the end you have the end user accessing a mobile device or an app on a mobile device. So first thing that you need to kind of ensure is authentication and authorization, which is the user itself who's logging on the mobile app, he needs to be authenticated and authorized as to which app he's accessing, which resources on the end system he's accessing, and whether he's authorized to look at it or not. The second thing, which actually comes in the development flow before one, is actually the API key validation or licensing of the API itself to the developer who is developing the app. So somebody is using your API and developing an app, and you need to provide an API key to that developer, and that kind of identifies the kind of operation that developer can access on your API. And there's a lot of things that API key, but it's not authenticating the end user. The end user authentication is a different step. API key is a different thing, and that's the distinction that most people who are starting off with APIs kind of misinterpret. That's a very, very important kind of differentiation. End user authentication and authorization is different, and API key, which is more of a developer, kind of identifies who the developer is, and you can license your API based on that. The other things are message security, which is as your API is going from the mobile app into your backend, how do you kind of prevent man-in-the-middle attacks? Then there is threat protection. How do you make sure that nobody is kind of doing denial of service attacks or invoking denial of service attacks against your backend server? How do you protect against virus? So there's content filtering. How do you kind of protect against malformed content? And then finally, rate limiting, which is monitoring. So let's go quickly into each one of these, and I just want to make sure that I don't go over my time. The first one is authentication and authorization. A lot of talk, a lot of very good talk over the last 3 days in this conference around various different things around authentication and authorization. A very kind of an important aspect over here from an API perspective is as the number of devices and web apps and IoTs, as it increases, the number of tokens and the variety of those tokens will keep on increasing. And the standards also, I mean, so right now there's OAuth, OAuth 2.0, there's OpenID Connect, there's SAML, there's a whole variant of various different number of tokens that you might have used on the end app, whether that end app resides on mobile or it. So you need to be able to federate those tokens, exchange, have a STS or something kind of that, and then go and validate, intercept the API, take the token, federate the token, mediate the token, and then validate against usually an identity and access management system, and there are two that are kind of coming out. There's the on-premise ones, which are mostly the Oracle and the Tivolis and of the world, and then there are, those are, I mean, you have online IDASS, and then maybe social login, which is coming to Facebook, Google, and Twitter. So over there, that comes, then comes OAuth. And OAuth is essentially, it allows a person to delegate constrained access from one app to another. So a lot of you kind of know about OAuth, a lot has been talked about it, but essentially it allows a user who has a direct account or who owns the resource as the resource server, it allows an app a delegated access to that resource without giving away his username, password, or credentials to the client app. So a very simple kind of flow for OAuth. This is Hootsuite. This is kind of one of the apps that I use to manage all my professional work social media. So you can sign in into Hootsuite using one of the social logins. Sign in with Twitter, Facebook, or Google. Once you log in, you are actually taken to a Twitter page wherein you log in, you provide your credentials, Twitter login, but you also provide the scopes, and these are called the OAuth scopes. So as part of the scope, you provide the permissions, which is update profile, post tweets on your behalf, access your direct messages. So you can go and define those OAuth scopes, which is essentially giving access to the app to some specific permissions. And once you authorize the app, you go and access that. So that's a very simple OAuth flow. But there's a lot of variants of OAuth flow, and implementing OAuth can be extremely complex. There's both client side, whereas on the client side, you need to implement OAuth, and on the server side. On the client side, there's the provisioning, there's the approval flow that you need to code, there's the UI, which kind of you just saw, which is kind of the flow. On the OAuth server side, which is on the server backend, you need identity integration, token validation, the OAuth token itself needs to be validated. The token needs to be reissued or refreshed, so all of that management, token mediation, and a bunch of different things around API, which is API proxying, policy management, reporting, and analytics around your OAuth token and how those services are being accessed. So OAuth is really hard, and you got to go and look at it. OAuth 1.0, 1.a was really hard. OAuth 2.0 kind of addressed a lot of complexities that were there in OAuth 1.0 and 1.0a. But it's still complex. It's still, I mean, a lot of developers kind of still have a nightmare around implementing or touching OAuth 2.0. So you kind of need to manage something like that, and there are vendors like us and others who kind of provide, like Solar Software and other kind of vendors who kind of provide OAuth server and kind of simplify some of these steps. The other step with API security is licensing. This is the step where, as an API provider, you provide an API key. And API keys are essentially provided to developers. I mean, somebody who comes and tries to access your API, they're provided usually an API key. And API key is a way of not only kind of providing access to a developer, there's a big security impact around API key as well. Whereas you license your API, you kind of restrict the access of which operation, how many operations, when can those operations, what the context of those operations. All those kinds of limitations can be applied on API key. So licensing is a very important aspect of API security. There's a business aspect of API licensing as well, which is You can have silver, premium, platinum licensing for API keys and for your APIs, and if you're monetizing your APIs, you can associate those licenses, but there's a security aspect as well. One of the hacks that happened last December with the Snapchat API, the biggest problem, there were multiple problems over there. One big problem was there was no rate limiting associated with that API. So essentially the hacker got access to the API. They also got access to the API key. And they could make multiple calls, and they, I think, got 300,000 accounts, usernames, phone numbers, and emails out of that because they just made multiple. There was no rate limiting associated with the API key or the monitoring infrastructure. The other thing that you need to do is message and parameter security, two different things. So message security is essentially the payload that's going in your API over the wire. And like Scott mentioned, use HTTPS. I mean, we kind of say, if you're using JSON, if you're using REST, use HTTPS, use it everywhere. If you're using SOAP or XML, WS Security obviously had ways of encrypting parts of your message rather than the whole HTTPS whole channel. You could do that, but in JSON, there's kind of new standards that are coming around, but right now the best way is to encrypt the entire channel, use HTTPS. For the parameter, so in your parameter, what happens is in the HTTP parameter, you might be passing your key. And this is exactly what was happening in Snapchat also. They just passed the key in their parameter. And this is, even if you use HTTPS, this is not getting encrypted. And this is really, really a bad practice and keeps on happening again and again in a lot of different places. And there are ways to circumvent around it, which is essentially one of the things is use HMAC. Always use HMAC, which is a hash-based message authentication code to obfuscate your API key. That's a best practice around a very simple way of ensuring that your API key, nobody comes in the middle, extract your replay your API key and gets access to your API. Moving on, two more things, threat protection. Now, with APIs, again, people can launch denial of service attacks. They can go and keep on calling your API, launch a denial of service attack on your backend, which is your backend or on your cloud, wherever your API is hosted. So how do you kind of go and prevent those denial of services? Kind of same issues that people keep on encountering on the web, on the HTTP web. The same issues exist with APIs. Injection attacks. The APIs themselves, the REST payload, or the JSON payload, or the XML payload, there's a propensity of injecting kind of SQL injection threats within those. So being able to go and validate your structure, validate the message, and extract out these injection attacks. Cross-site scripting, network address range, blacklist, whitelist, HTTP parameter stuffing, some other kind of ways through which you just need to be aware of all of these parameters. There's some use case around each one of these that hackers have potentially used to hack an API. And the last one is content filtering. Content filtering, again, which is more around just the message structure of what you have, whether it's JSON or whether you have XML, being able to validate that. A lot of times, your consumer, especially if you have an open API, the consumer of API could be a irresponsible developer or kind of an OIS developer who might send a malformed a JSON package, which you don't know how your end application is dealing with it. So being able to go and validate those data structures and have policies for your XML and JSON data packages. And obviously, virus scanning. Actually, this is the last one. And the last one is around quota monitoring, which is have monitoring in place. Your APIs, how many times is this being called? Where is it being called for? The number of apps, having some context around it, which is it being called from a mobile app? Who's calling it? Where is he calling from? So all kind of different monitoring, don't forget it, and monitoring, again, And also doing rate limitings, which is if you have a license that's tied to how many times an API is being called, and go and enforce it, and then have a proper alerting mechanism so that you can stop or take preventive actions against it. So that kind of brings me to the end. There's an API gateway. There are a lot of API gateways in the market. There are some of these capabilities that you should look into an API gateway. There are specifically comes back to what I started off with. There's API security, and there's API security specific threats, which API gateways handle. So they do security, they do authentication. They are essentially for authentication and authorization. They should be able to tie to identity and access management providers. Do encryption, quality of service. But to a certain extent, what an API gateway also does is orchestration, paging and caching for mobile optimization or IoT optimization, scripting. Some of these capabilities are kind of unique to API gateways. So that is kind of end to my presentation. I'm probably 4 minutes earlier. But there are a lot of resources on API security and API university on resource.soa.com. Feel free to go there and get that content. Or you can even contact us at SOA Software Inc. at Twitter, or myself at Sachin Agarwal. Thank you. So the question was, what's the best strategy to protect your APIs against distributed attacks? So like I mentioned, denial of service attacks. So what the best practice for denial of service attack is to have first an API gateway kind of infrastructure that is intercepting all your API traffic and looking at which are the authentic requests or not, and being able to detect that there's a denial of service attack that's going on, and stop it over there. The other is, what I mostly suggest customers is having something as a sacrificial lamb. Your API gateway, your infrastructure, whatever infrastructure that you're protecting, whether it's on the cloud or on premise, fronted by something on the cloud, like an API gateway on the cloud, which can act as a sacrificial lamb, which goes down on a denial of service attack and doesn't bring the application down. And if it's on the cloud, obviously, it's scaling. It scales with demand, but sometimes it doesn't. But that API gateway or infrastructure acts as the sacrificial lamb, not your application or the hosting infrastructure. Yeah, the gateway. So your gateway is not running your API. The gateway is just a facade in front of your API, kind of trying to protect access to it. Yeah. Okay. Any more? I'll be outside, or I'll be here in front with Scott and my other speaker, sorry, Justin. So, but thank you.
Thank you.